Hello, my name is Jürgen Münch. I'm working as professor for software engineering and software innovation at Reutlingen University. I'm focusing my research, my teaching and also my industry transfer activities on different areas, especially on lean product management and on agile engineering. In the area of lean product management, I'm working on topics such as software startups, lean startup approaches, or design thinking approaches. Here I'm collaborating with several companies. For instance, I'm collaborating with MySecondWay, and here I'm studying and also supporting MySecondWay in lean product development and also lean service creation in order to create value for their customers and to create products that really customers want and love. I'm also collaborating with other companies like Ericsson, F-Secure, or startups like Telebeam in this area. Another area is agile engineering. Here we try to introduce agile processes and more agility in so-called regulated domains such as automotive or healthcare. And in these areas it's not so easy to get more agile. So what we are doing is to integrate traditional processes with more agile practices into the so-called hybrid processes, or integrating product line engineering with agile processes. We are doing this, for instance, together with Daimler in the area of the development of electronic control units. Overall, the collaboration with MySecondWay is very fruitful because here we can analyze the challenges and also support MySecondWay in creating products in highly relevant, future-oriented topics such as artificial intelligence and general artificial intelligence.
My name is Ilya Petrov. I'm professor for data processing and data management at the University of Applied Sciences in Reutlingen. Here, I'm chairing the Data Management Lab. The focus of my research at the Data Management Lab is high-performance data management, especially data management on modern hardware. I'm especially interested in processing large data sets by employing the full potential of the underlying hardware. Very complex data processing problems have emerged right on the verge between large-scale machine learning and high-performance data management. And this is where the focal point of my research activities is. I'm working gladly with startups such as MySecondWay because they offer a very fruitful environment for innovation. They have short innovation cycles. It's very easy to deploy new ideas and play with them. And it's also free from the typical university constraints and typical organizational constraints you would find in large companies. With MySecondWay, it is especially useful for me to exploit how I can get data from the prototypes we have been implementing. How can I use them to verify research hypotheses, and how can I use those research hypotheses for new research? Besides, it is especially interesting for me how can I find new problems that build on top of the research we have already implemented in existing products. The combination of high-performance data processing on large data sets combined with large-scale machine learning provides the foundation for practical AI these days.
In this video, I want to show how AGI reasoning and pattern matching works. To demonstrate this, we use a clean, build-up from scratch AGI system with no information. Then we load some sentences into the system and we'll see what the AGI system can do with the new information. To keep this demonstration simple, we use an example for deductive reasoning. If you don't know anything about deductive reasoning, let me explain what deduction means. Deductive reasoning determines whether the truth of a conclusion can be determined for that rule based solely on the truth of the premises. An example for this is when it's raining, then the streets get wet. And when the streets are wet, then take care driving a car. Therefore, when it's raining, then take care driving a car. But first we want to ask our chatbot if it can answer us the question, who's gorgeous? Since we use a new empty system, we expect no answer. The name of the chatbot is April, which is the acronym for AGI Product Planning Interaction Link. So let's ask April. April, do an inference search.
What would you like me to infer?
Who is gorgeous?
I'm sorry. I have no information to answer the question. Who is gorgeous?
As expected, April cannot answer us the question who is gorgeous, since the AGI system has no information inside. So let's start filling some information into the AGI system, and therefore we use a very simple example where we have 20 humans. We put inside the AGI system some sentences like Alan is a human, Abe is a human, Lucy is a human, and we say there are 10 men, Alan is a man, Abe is a man, and we say there are 10 women, Lily is a woman, Emily is a woman, and we say there are 5 gorgeous men, Alan is gorgeous, Kaysen is gorgeous, and we say there are 5 gorgeous women, Lily is gorgeous, Lucy is gorgeous, and we say there are 7 soda drinkers who are male, Alan is a soda drinker and Abe is a soda drinker and so on. And we say there are 5 soda drinkers who are female, Jessie is a soda drinker, Jenica is a soda drinker, and then we put this information into the AGI system. We check at first, do we have any patterns found? We refresh this page. There are no patterns found. Now we say load this information to the system and then check what the AGI system can tell us about our question, who is gorgeous. Okay, let's load these examples. It's finished. The AGI system sent us back any new found patterns so that we can see what it has learned. The results are sent back via Kafka. We use our BOSON architecture to get these results and insert them into a database to be viewed in a convenient way. So let's have a look at NiFi and see if we have any results from the AGI system. Yes, we have. We got 3 patterns and we insert the patterns into a database. And now let's have a look what we can see here. We do a refresh there once again. And here we can see what the AGI system has learned. There are human who are women. There are human who are men. And we can step down and see men are soda drinker, human are soda drinker, human who are soda drinking are gorgeous. And we can see that human are soda drinker and we can see that human men who drink soda are gorgeous. So next we're gonna ask April again to see what April can say now about the question, who is gorgeous? April, do an inference search.
What would you like me to infer?
Who is gorgeous?
The answer to your question, who is gorgeous, is human man who are soda drinker are gorgeous.
This is not bad for the small kind of sentences we inserted into the AGI system. So what you have to think of is this is only one kind part of the AGI system. It shows how one part of reasoning works. And reasoning is only one small part in the AGI system. There's a lot of more things the AGI system can do, not only reasoning at all. Now think of what can be done if we combine all parts of an AGI system and feed the system with all important informations we can get from the world. Imagine to ask the system, April, what do my customers usually order on a rainy summer day? There is no coding, no aggregation, and no collecting of any data. Just asking April what you want from the system and get the right answer back.
This chart summarizes the relationship between price levels and gross domestic product, or GDP, per capita, of economies in the world, while also showing the respective size of each economy, based on the results from the 2011 International Comparison Program, or ICP. Let's see how it's constructed. These two bubbles represent the GDPs of India and Germany in their local currencies. But the sizes of the bubbles are not yet comparable, since one is in Indian rupee and the other in euro. In order to compare them, they need to be in the same currency. So let's convert them into US dollars. Do we use market exchange rates? No. To compare the real size of world economies, purchasing power parities, or PPPs, are the better measure, because not only do they express economic output in a common currency, they also adjust for differences in price levels across economies. Using PPPs, we can convert the GDP of each economy into real terms. Let's add Brazil. To compare standards of living across different economies, let's align them by GDP per capita, which is GDP divided by population. The horizontal axis expresses GDP per capita in PPP terms, with the lowest GDP per capita on the left and the highest on the right. Adding the remaining economies, the sizes of the bubbles and their location on the horizontal line show the relationship between GDP and GDP per capita, both in PPP terms, of the world's economies. The vertical axis shows price level. Let's examine what it means. Suppose you can buy this basket of goods with 100 coins in your country. If you travel to India, a basket of the same quantity and quality of goods would cost about 3,600 rupees, which can be exchanged using the market exchange rate into 42 coins of your local currency. If you go to Germany, the same basket would cost about 55 euros or 140 of your coins, again using the market exchange rate. Hence, the same basket of goods is more expensive in Germany and less expensive in India relative to your country. If we set the price level reference to the basket in your country as 100, then the price level for India is 42 and for Germany 140. To understand this better, let's consider the price level index, or PLI, which is the ratio of an economy's PPP to its market exchange rate. PLIs provide a measure of the differences in price levels between economies by indicating the number of units of the common currency needed to buy the same quantity in each economy. If the world average price level is set at 100, then an economy with a PLI higher than 100 is relatively more expensive compared to the world average. If its PLI is lower than 100, then the opposite would be true. Now, let's bring back the three circles. Here, the world average PLI is set at 100. Let's align the economies vertically, by their price levels. India appears to be relatively less expensive compared to the world average. Germany is relatively more expensive. Brazil is closest to the world average among the three. Let's bring in other economies from Africa, Asia and the Pacific, the Commonwealth of Independent States, Eurostat, OECD, Latin America, the Caribbean, and Western Asia. Now you can see more clearly the relationship between price levels, GDP per capita of economies, and the real size of economies. You may spot some noteworthy patterns by region or by specific groupings of economies. This chart can also be utilized for in-depth analyses of various GDP components, such as individual consumption, government consumption, gross fixed capital formation, and so forth. Using time series data is also informative. The World Bank's World Development Indicators publish GDP and PPP time series that you can use to measure and track changes in economic trends over time. These data visualizations enable better understanding and analysis of the structure of the world economy.